Hi everyone, today I want to present our proposal for extending the Universal Variability Language with optional language levels and conversion strategies between them. The initial language proposal for UVL is rather simple, as we can see in this example. The feature models are limited to Boolean logic in the tree hierarchy and in the cross-tree constraints. For example, each pizza requires cheese and one type of sauce. Also, ananas can only be selected in combination with ham. With the initial version, we can also attach information via feature attributes. Here we annotated each ingredient with a number of calories. Also, the type of dough is indicated. This simple version of UVL comes with some limitations. As we are limited to Boolean values and constraints over the features, we cannot specify any constraints on the attributes. To support tailoring UVL for specific use cases, we introduce optional language levels that encapsulate different language features. As first additional language level, we propose simple arithmetic constraints over feature attributes. Here, we added a constraint that limits the overall sum of calories for the ingredients. As a second language level, we added new feature types in addition to Boolean features. For example, the cheese feature is now an integer. A customer can now select the amount of cheese. However, we also added a constraint forbidding more than 300 grams of cheese selected. The greetings on the box feature is now also a string feature and can be at most 100 characters long. The idea of language levels is to maintain a simple base language that many tools can handle and analyze, but also have more sophisticated expressions. Developers can then decide which levels of UVL to support within their tool. The idea is to group language features regarding the reasoning engine that could be used. So for example, if your tool is using a SAT solver, selecting the Boolean level would be sensible. There is, however, one major problem with such language levels: the exchange of UVL models between tools supporting different levels. Suppose my tool only supports Boolean expressions. I would have a hard time to use a UVL model including arithmetic constraints. To vastly simplify the exchange, we propose conversion strategies between the levels. Here, language constructs are replaced with equivalent expressions from a lower language level. Let's take a look at an example conversion. On the left side, we can see a simple UVL model containing an arithmetic constraint limiting the overall rate of the features. On the right, we see the result of applying a conversion strategy to an equivalent Boolean model. We implemented those conversion strategies once in our parser. Each tool using the parser can then easily invoke the conversions and thus can also manage UVL models with more complex language levels. Let's take a look at an example project. Here we can see a simple project using our UVLParser library. With our tool, we already used the library to parse the UVL model. However, our tool only supports the arithmetic and lower language levels. Hence, we may run into problems here. For instance, our input UVL model contains typed expressions and our analysis cannot handle them. So, let's add a line to automatically convert language levels that are too complex. We give the input modelizer the input to our method and also specify the language level we want to support. This line now automatically converts all language levels that are too complex for the arithmetic level. Now we can run our tool and invoke the analysis of the converted model. So, when using our tool UVLParser, you do not need to worry about unsupported language levels, as you can just delegate the conversion.